If a supereruption were to occur, the blast would launch enough ash into the atmosphere to disrupt weather for years to follow, potentially causing famine, health crisis, and global civil unrest. And leading up to the catastrophic event, the world would have just 1 year to prepare. Researchers have determined this based on a microscopic analysis of quartz crystals in pumice from the Bishop Tuff in California, the site of a super-eruption 760,000 years ago. The ancient super-eruption in eastern California formed the Long Valley caldera, a feature that is nearly 20 miles long and 11 miles wide. In the study, the researchers from Vanderbilt University and the University of Chicago analyzed dozens of small quartz crystals, remnants from the original underground magma, from the Bishop Tuff. Quartz crystals have distinctive rims, they explain in a paper published to the journal PLOS One, and are rich in titanium. Along with this, they are bright in cathodoluminescence, which allowed them to make high-resolution measurements of variation in the titanium, providing detailed insight on the transition from pre-eruptive crystallization to the decompression and crystallization at the time of the blast. This analysis helped to determine rim growth times and growth rates, revealing that these processes largely occurred in a span of less than a year. Maximum rim growth times spanned from approximately 1 minute to 35 years, with a median of approximately 4 days, the authors wrote. More than 70% of rim growth times are less than 1 year, showing that quartz rims have mostly grown in the days to months prior to eruption. Growth took place under conditions of high supersaturation, suggesting that rim growth marks the onset of decompression and the transition from pre-eruptive to syn-eruptive conditions. It takes tens of thousands of years for the crust to generate enough eruptible magma, but once formed, these unstable magma bodies only last for centuries to a few millennia. As the decompression occurs, the magma body would likely be expanding as well, having detectable effects at the surface. The evolution of a giant, super-eruption feeding magma body is characterized by events taking place at a variety of timescales, said Guilherme Gualda, Associate Professor of Earth and Environment Sciences at Vanderbilt University. Now we have shown that the onset of the process of decompression, which releases the gas bubbles that power the eruption, starts less than a year before the eruption. These findings indicate that the signs of a super-eruption would likely be felt within a year of the event, growing stronger as it approached. But, they say there is still more work to be done to determine what these signs would be. Around the world, there have been numerous super-eruptions in Earth's recent history. The most recent, the Orwanwi eruption at the Taupo volcanic zone in New Zealand, took place 26,500 years ago. Before this, there were massive eruptions in Italy, Indonesia, and the United States, where Yellowstone released 3 super-eruptions in the last 2 million years. And, this geological history indicates another super-eruption is most likely inevitable, though not for quite some time. As far as we can determine, none of these places currently house the type of melt-rich, giant magma body needed to produce a super-eruption, said Gualda. However, they are places where super-eruptions have happened in the past, so are more likely to happen in the future.